newsfeed team. Today, I will talk to you about the process in which we transitioned at Facebook from a company that was mostly a main desktop application to one that is mobile first. So let me start with a story. It's 2009, and at Facebook we have a handful of engineers working on mobile. The rest of the company is focusing on the website. PMs, designers, engineers, all of them think about products first on www. Well, very soon we realized that this was not going to go well for our users. What was happening was that the mobile engineering team was behind in terms of product development. The teams focusing on the desktop website would build their products, and the mobile engineering team would try to catch up by building them one by one. Well, at this point, we knew, okay, people are not going to settle with suboptimal experiences or fractions of the main website. So we started building fully native experiences across Android and iOS. The mobile team started building these experiences like the newsfeed, timeline, groups, etc. And after they were done, they would hand off all of this new code to the product teams to own. Fast forward a couple months from that, and we no longer have a mobile engineering team. The whole company is focused on mobile. We said, okay, forget about this setup where you have a team that is building your experience and then you tweak it and continue. Instead, we want all PMs, designers, and engineers to start thinking mobile first and building those experiences there, designing them there. Cool. So this is, in a quick nutshell, how we grew as a company that cares about mobile. We also have grown a lot in terms of mobile monthly active users. As of today, we support over 1.4 billion users in mobile, and this number is growing every single day. Sorry. Android itself has grown a lot too. This is a projection of the number of internet-connected devices running Android in the world. This is not Facebook specific. And this graph is pretty exciting to see. In fact, even as of today, Android has the majority of the smartphone ecosystem here. So today's talk is to learn a little bit about the mobile landscape at Facebook. As I mentioned, we support over 1.4 billion mobile monthly actives. We also ship really fast. In fact, we ship a new APK every week, and this one is packed with features built by dozens of engineering teams. These are hundreds of code changes. Now that's not easy because we have a lot of features in a single app or in a couple apps with hundreds of engineers working on them. And if you really think about our app back in 2009 when it started compared to today, our mobile application has a ton more features. They are focused on mobile experiences, and the app is a lot more performant too. At the end of the day, we have very low tolerance for error. Mostly, a lot of you guys know this, but apps are citizens of the operating system. That means that even if you have a small feature that is utilizing resources in the wrong way, say having a lot of memory leaks, this small feature, if it had been on a website, we could contain it by either not opening that part or just not rendering that section. But in a mobile application, what happens is it's the general pool of resources. So the operating system will kill you if we're not writing the right code. Okay? So very high bar. We need to move really fast, and we have a lot of people who expect high quality experiences. Today, I'll tell you a series of stories of how Facebook transitioned from a small company that started from a website to one that cares about mobile as the first priority. The first part is coding at scale. A little bit about, hey, what happens when you transition from 10 engineers or so working on your mobile code base, and then suddenly you have hundreds of people committing to the same code base. How do you find more people to grow the company that is mobile, etc.? The second part is releasing to the world. What is this process like and what happens afterward? What signals do we get back? So let's start with coding at scale. Now, this is back in 2012. I remember this time when we decided, hey, everyone who is an engineer on a product team is going to start working on mobile as well. So almost like overnight, we transitioned from having a code base manned by like 12 people to a little bit over 100. So I remember this was a little scary because it was impossible to build a code base. And even if you managed to build it, when you install it on your phone, it would crash all the time. And there was no way we could move fast if every time we made a change, we broke something, or we thought, oh, all these people are breaking this. We couldn't even test our features. So one of the things I realized is that we would have to make very big, some foundational changes for this model to work out. First, we had to enforce testing. We would have to create a model that allowed testing so that we could avoid writing brutal code. The second part was we had to break dependencies amongst teams. In other words, if newsfeed is broken, the messenger team shouldn't suffer at this point. We should be building each of these verticals separately and connecting them at the end. Cool. So this is a time when, back in 2012, we started using Dependency Injection as a company. For those of you who are not familiar with this Dependency Injection, actually, let's do a show of hands. Who is not familiar with Dependency Injection? Oh, very few people. Cool. So, okay, I'll go quickly here. It's a pattern for externally setting object dependencies, and it separates the behavior of the object from its creation. And at the end of the day, it encourages modularity and testability. Here's an example. Let's say if we were to create a newsfeed fetcher, we would have to have a bunch of dependencies. Let's say something that makes an HTTP request, something that parses the JSON from that HTTP request when it comes back, something that downloads the images. So each of these are dependencies that this fetcher would have. So if we were to write it in a naive way, it would look something like this. Oh, I think I skipped too fast. Cool. So if we were to write this naively, it would look like this. Hey, within the constructor, create each of the dependencies and work with them. What are some of the problems here? First of all, it's impossible to write a test. Okay, you need network access to check this method, this fetch newsfeed method, probably. What if I want to switch to use a different JSON parser because I'm doing some sort of experimentation in a separate branch? So then you have to write some if, something, something, and suddenly you're tangling a lot of the implementation within your code. The last part is that if something is broken in, say, the downloader or the parser, there's really no way to identify which part this is broken into. Okay? So the solution here is that DI proposes is to invert the control of your object, ownership and the creation of its dependencies. Instead of creating new object so-and-so within your constructor or within the body of your function, we will just say, hey, pass me fetch an HTTP request helper or a JSON parser or an image downloader. I don't have specific instructions of how this should be created, but just pass it to me and I need it to have the specifications. The nice thing about this is that if I'm running a test, I can just pass a mock JSON parser, a mock image downloader, and I don't have to be depending on the network. Or the other part is that if I want to fetch this newsfeed not within the main app, but say within our standalone groups app, we can switch to the resolution of a different URL, or this can be called in a separate setup. So, since most of this audience is familiar with this, you guys are familiar with this inject annotation. The nice thing about it says, hey, DI framework, when you start the app, if anyone is asking for a fetch newsfeed method, create one by passing objects of this signature. Cool. So, As you already know, this is helpful for writing much code that is much more testable. The code is much more modular, and it eventually helped us scale our code base. Right now, we have hundreds of engineers working on dozens of different products, and we can reuse a lot of our code that way. And we can also break our dependencies. However, one of the problems that we ran into was performance. Creating a lot of these dependencies doesn't come for free. So let me tell you about one particular case where this is a problem. It's in dependency resolution. We're saying dependency injection framework. When you start the app, figure out this mapper of classes that I need to the actual providers that I need. So it just checks for each one of them and it creates every single object just at startup time for most of them. But it still has to create this resolution mappers. So that's nice because it gives you the flexibility. The problem is that creating each one of them, when you have a ton of them, when you have thousands of objects, can get really nasty. Now, so what did we do? One of the engineers suggested, hey, instead of doing this at runtime, why don't we create all of this mapping from classes to providers at compile time? Because you can figure out which ones the actual application will need at that time. The flexibility is so that we can write better code and we can write tests for it, right? So what he did is he modified the Java bytecode to substitute the provider creation to have static classes themselves. So a change like this helped us reduce cold start by around 20%. Now, this is not something that you run into immediately. This performance problem is not something that you run into immediately when we start applying dependency injection. But at the Facebook scale, where we have hundreds and hundreds of classes being created and accumulated probably as we build more features, this is something that we had to handle. Now, at this point, there were a lot of advantages. So instead of, hey, ripping off dependency injection, we have focused on teams that look at the compilation, compiler optimizations in this case. Cool. So the other part I want to talk about is testability. So this is a screenshot of a diff for review. I have blurred a lot of the internal details, which are not important here. But what I want you to focus on is the green and the red rectangles in there. Every time a diff goes out for review, we kick off a bunch of unit tests for them. You know, the most common thing is that when we send out a diff, we think that, hey, it's well tested. I have tried it a couple times, and being good citizens, we are like, okay, no, I don't think this is going to break. However, when you're dealing with a code base that is so big, where these pieces can be reused in very different areas, for instance, a news feed could be reused in a groups feed or a pages manager feed. A comments popover, like the comments flyer, could be reused in dozens of different sites. We might not realize that we might be breaking something else. So we need to make sure that all of these tests are in place so that by the time we check this in, we can resolve each of them and we do not break master. Cool. The next topic I want to talk about is common APIs. Now, it's pretty standard, no matter what you're building. In the situation of an app, we will need to fetch some data, store it somewhere, and render it somewhere for the user. Okay? Cool. Nothing new here. So our engineers have to write some sort of code for this. So imagine, again, scale this to dozens of engineering teams. Newsfeed is fetching all of the fields to render all the stories that your friends that are related to your friends, timeline, each of the fields, events, groups, etc. And for each one of them, the model is pretty simple. You need to fetch some data and you need to store it in some sort of model, and you need to display it. Now, because the fields and the model is different across the different features, we have to write like separate pieces of code, right? So one day, one of our engineers said, okay, hey, I want to refactor some of this model structuring. And this will be much faster and it will use less memory. But Now, back to the Facebook scale, when we have dozens of engineering teams scaling, like writing a lot of code, and a lot of it, this code looks almost the same, but not exactly. When he tried to make the changes to all of the different call sites, inevitably there were bugs. He broke certain things. He pulled a lot of content. He refactored some code, and some things broke. Mostly, I mean, it's not really his fault because he is not the owner of that direct piece of code, but this had to be changed, right? So these things would happen every so often. So what we did is we changed this model. Instead of breaking stuff, we said, let's create a small file where we specify what type of data we want to download. Let's say for Messenger, it is the thread list of your messages with the message field, the actor name, etc. For newsfeed, it will be the stories, the attachment, if it's a link or it's a photo. For events, they will have their own custom fields. So all of it is specified here. And what we changed to is we created a script to auto-generate all the boilerplate code to take all of these fields into native access, like Java accessors for the model. That way, whenever we want to actually change something in the way the data is stored or processed, what we can do is change the boilerplate script as opposed to the details for each team. So the teams that focus on changes like this are called product infrastructure teams. Their objective is to build the right APIs so that the product teams don't have to be reinventing the wheel and creating more and more abstractions on their own. Because chances are that if Timeline has certain needs, Newsfeed has them too. So no need to be rewriting them over and over. Cool. So these are two examples of how we have changed our code base, and this is a byproduct of having more and more engineers committing to the code base. Now, the other part I want to talk about is less coding specific, but it is people specific, and it is on how to hire mobile talent. So this graph shows the growth of Facebook as number of employees in the last couple of years. So we've grown a lot. Our user base has also grown a lot. There's a huge demand. However, as you guys probably know this, it's really hard to hire mobile engineers. We've grown this much, and we wanted to be a mobile-first company. But it turns out that hiring enough mobile engineers, is quite hard, right? So how do we do this? Actually, can we do a show of hands, and can you tell me, in your different companies, are you guys having trouble hiring mobile engineers too? Okay, cool. So it's like a common pain. So our story is less about hiring; it's about training. Another poll. How many of you guys used to develop on Android? Well, how many of you guys used to develop in a different platform before switching to Android? The majority, right? Android is pretty new, so chances are that you have been developing for different platforms before. So this is something that we noticed too. When we switched from having a small mobile engineering team and we encouraged all of the product teams to jump in, we were also looking for systems engineers who were interested in switching to mobile. Some of our strongest leaders at Facebook working on Android and iOS did not start just from this particular platforms. They were building scalable and efficient systems in different stacks. But there was a problem. We had a lot of people interested in mobile. We had a lot of people interested in making the switch because there was a lot of impact. However, at the early stages, it was a little messy. We didn't know exactly how our code should be structured. The dependency injection framework that we had built internally had just been placed, and ramping people up to speed took a while. Imagine, it's not that people didn't know how to write the code, but people had a lot of opinions of, hey, should we be doing it this way? Should we be doing it this other way? Now, we're talking about 100 people with different opinions about how this should be done better. So, I mean, at the end, we had a lot of different APIs stayed, some evolved, and some continued. But we found out that if we kept injecting more and more people into mobile, we had to create some sort of training. At Facebook, every new engineer that comes to the company spends 6 to 8 weeks learning about the different parts of the code base. They also get to learn about the internal tools that we use so that they can hit the ground running fast when they join a team. So what we did is we created two specialized tracks, one for Android and one for iOS. This was a little different from our generalist or web stack track. In this classes, you get to learn about just very basic Android or iOS 101, like activities, fragments, etc. And that's your first week. After that, you get to learn about the different architectural decisions we have made across our common APIs. How is our DA framework built? How is it different? How did we decide to go split from juice and rovo juice and why? Or how are our APIs? How do you fetch data? What is this opinionated way of writing good code? Everyone should be writing tests. This is how do you write view hierarchies that are efficient and flat? And why is this important? So by doing this, we were able to unlock all of this interest and talent that was interested in transitioning to mobile. And this is pretty much how we built and keep growing under our engineering teams. Cool. Now, one thing to note is that these classes are taught by Facebook engineers. We found that this is very useful because you get to meet each other, but you also get to discuss what are the trade-offs of your design decisions directly and get a lot of feedback from people. Cool. So we talked about how to code at scale and how to grow an engineering team at scale. The next topic I want to talk about, I want to cover is releasing to the world. So at Facebook, we want to make sure that every single feature or every single APK that we release to the world is stable and the features are bug-free. So how do we do this? We release our APK in different phases. Now, one of the biggest challenges is that our app is being run in over 10,000 different devices, which is pretty challenging. So the nice thing about Facebook is that everyone at Facebook uses the product. So we are our own customers. So the first phase when we have a feature or a new APK built is employee dogfooding. The idea is everyone who has an Android phone at the company gets the latest build. And sometimes there are going to be mistakes. There are going to be some bugs. And we want to provide them the tools so that they can report them as soon as possible. So if you see a problem, you shake your phone. We have this feature called Rage Shake when you're really pissed at your phone for not working. And then you get to go through the bug reporting flow. But employee dogfooding is not enough. We also lean on the different alpha and beta channels that Google Play Services provides. And in the alpha channel, we have over 100,000 alpha testers. The beta channel has over 1 million beta testers. We mostly use these channels to understand stability and crashes so that by the time we are releasing something to the world, this won't be a major problem. And when everything is ready, when we have tested everything, we release this to the world. However, so this helps for the majority of cases, and this process has helped us a lot to ship our APK once a week, which is pretty aggressive for us. However, sometimes there will be some bugs too that will leak out to the public. Let me talk about a photo upload bug that we had a while back. So let me walk you through some details. But if on Android you want to create a formatted string that says, hey, we're uploading photos and we're at 70%, you will have code that looks like this, with the %d as a placeholder for the 70 or the whatever number you have. And if you want to do the % sign, you have to escape it with 2% sign. Cool. Now, when we passed our code, our strings for translation, it turns out that our translation for Danish, Polish, and Finnish look like this. However, the translators there thought, oh, hey, those 2% signs look like a mistake, so I'm just going to remove it. They look like a typo. So the problem with this is that we didn't have a direct crash. We were silently failing. And for Danish, Polish, and Finnish, this just didn't work when you uploaded photos, which is kind of crappy. This is back in the day when we had a release every month. So for a month, they couldn't. It was hard for us to detect this because this was a particular user flow that was only on Gingerbread. So even on the beta channel, we only had three instances. You had to be uploading a photo in Denmark, Poland, or Finland in a Gingerbread phone, which is unfortunate. The nice thing was that we were able to see this happening with our internal analytics. We log the number of uploads and we can slice by different dimensions. And we saw a spike in upload failures in our backend. We noticed this, we submitted this fix, and this was fixed by the next release. Okay. So let me give you a summary of where we get all of the information about what's happening to our app in the world. We rely on crash logs. We also rely a lot on bug reports, both external through the alpha beta channels and our employee dog fooding, but also our Google Play Store reviews. So if you think about these sources of information, they come in forms of small, short snippets of plain text. They are not structured because someone is saying, hey, my newsfeed is not loading, my photos are not, I can't like, etc. At the volume that we get, it's impossible to read each one. So what we do is we rely on our internal infrastructure, our internal distributed infrastructure for data processing, and we use natural language processing to cluster each of these reports into different issues and topic areas. For instance, users can't like, photos are not loading, etc. That way we can know which are the what's the severity of each issue and reproduce a lot of these issues. This is also a way in which we can find out the top user requests, and we can build new features on top of our app. Cool. Now, this is a screenshot of what our engineers get to see when they have a crash assigned to them. Again, I have blurred a lot of the internals here, but what I want you to focus on is, on the left, they get a full stack trace. What is the issue? On the right side, you get aggregated crash summaries. How often is this happening? What versions? Which release? Etc. That way they can reproduce this quickly and fix it. By having tools like this, initially we were able to reduce our crash rate by about 75%. So a lot of awareness, breaking dependencies, giving the right signals and tools to our engineers is what has helped us move really fast and release apps every week. Cool. So, but is this enough? I broadly mentioned the 10,000 device problem. Obviously, that gives a signal of what's happening, but it doesn't tell us how to build features for each one of them. So, in the past, we used to slice our users by the operating system that they were running. A Gingerbread phone was very different from one that was running ICS. And one that was running ICS was quite different from one that was running Jelly Bean. However, in the recent number of years, hardware has become very, very affordable. And you can see, say, Jelly Bean or KitKat phones that are running low-end hardware. Take this phone, for instance, the Moto E. It was released in 2014. It has 2 CPU cores. It has 1.2 gigahertz of clock speed and 1 gig of RAM. Okay, not necessarily the fastest phone for 2014, but when we compare it against the Galaxy S2, it's very, very similar. The Galaxy S2 was top of the line back in 2011. Okay, but they have 3 years. They are 3 years apart in release. So instead of thinking, hey, does this run Jelly Bean or KitKat or Gingerbread? What we do now is we think both of these phones are year class 2011. And what is this year class thing? The device year class concept that we introduced was, in what year would a given phone have been considered top of the line? That way, instead of working with 10,000 different devices, we work with 7 or 8. Okay? But this is not just for testing. This is for understanding what our users are used to. We get to run statistics of the composition of each of this type of phones around them. There. Now, living in the Bay Area, we're in a bit of a bubble where we might see everyone around us using very new high-end hardware. But that's not the reality in the world. Okay. In fact, what we do is we have different user study programs where we have small groups of engineers from across different teams go to different markets. For instance, emerging markets like India or Nigeria, or to understand, hey, what's happening with countries like in Southeast Asia, where people tend to use our app different from, hey, South America. One of the things this does and helps us a lot is we get to interview our users and build a lot of empathy over what's busted in those markets, and something that we might not realize because we're using high-end phones. If you look at this graph, it shows you the majority of the world is running old hardware that was high-end in 2011. So we need to make sure that we're building experiences for everyone, not just for ourselves. Here's an example of something where the year class classification model helped us a lot. A couple of weeks ago, we launched this feature called reactions. And the idea is that if you press and hold and the like button, you get to express yourself with something beyond the like. So this was pretty cool, and our designers and engineers wanted to create very delightful, fun experiences. Look at those animations. They really liven the feature, and they're pretty cool to see. However, the first thing that we looked at when we were checking out this design is, oh, what are we going to do with low-end hardware? Obviously, right? Is the API for drawing in the canvas even available for anything below, I think, Jelly Bean? The answer is no. So what we did is that we split this for year class 2011 and below, and anything below Jelly Bean, we don't have an animation. You still have the core functionality. And even if we could draw the animation, it might be choppy because you don't have enough, like, the hardware to render all of this. So for high end, we kept the beautiful animation, and for low end, we kept static images. Cool. And this is an example of a feature where this applies, and we keep thinking about different year class models for different features that we use. Cool. Another way to also look into the spread of our users is network connection class. So this is a separate dimension. We have created a classification that allows us to bucket connectivity into two separate classes. That way, instead of just building for a one-size-fits-all connection or assuming that everything is excellent connectivity, we build for each of the different cases. So what does that mean? Well, you might... This is not just a problem. This problem exists everywhere, but it's especially worse in emerging markets. However, even for us with high-speed LTE connections, we might see cases where thinking about different connectivity setups would make sense. Think about the case of being in a subway or in a stadium or in an airplane, and I can keep going on and on about places where you might run out of internet connectivity. So let me give you an example of a feature that was tuned for that. So it's a story about selective prefetching. Let's say you're going through your feed and you go and read through the stories. And for this particular story from Alex, I'd like to read the comments, but I'm in a place with no good connection. So I get to see this infinite spinner, which is not cool at all. Okay, that's just standard now, unfortunately. But, however, what is the other option? We could just download the comments together with the story payload and show them to you. Now, it turns out that not everyone opens the comments for all of the stories they see. Sometimes they just glance through them, and if they're not interested, they continue. The problem here is that we could be breaking your data plan, okay? Or we could be fetching a lot more data that you're not even using. Okay, so those are two crappy solutions: infinite spinner or using a lot of your data. In fact, it might not just be using a lot of your data, but affecting your scrolling performance because we're downloading a lot of stuff. So what we came up with is something in the middle. We created a model that prefetches comments for stories in a selective way. We created a machine learning model on the backend that calculates the probability that you'll be interested in reading the comment for each story. We can do so by looking at the like-through and click-through rate that you have for all the stories, learning a model, and predicting it for the next story. And what happens is when we load the stories, we download the story payload first, and if there's some time and the network is not being used, we will selectively download the comments for a fraction of them. That way, we don't download everything and we don't use a lot of your data, but still you have something. It turns out that if you're in excellent connectivity, this does not make a difference whatsoever. People get a tiny spinner, like a spinner for a couple for a short period of time, and then they quickly get their comments. So it's not that they comment more. But if you are in a bad network, that's a difference between an infinite spinner and having some content to have. In the same way, the difference between offline comments, having the ability to comment offline, is much more pronounced in in poor or moderate connectivity setups. Cool. So both of these APIs are available and open sourced. So if you guys are interested in checking this out, so that instead of thinking jelly bean or gingerbread, which doesn't have that much of the market anymore, you can think about year class. It will help you segment your users a lot more easily, both in year class and connection class. That's all I have for today. I know it's like a broad overview of a bunch of the challenges that we have run into. There are a bunch of talks here from Facebook folks focusing on video. And there was a talk early in the morning about emerging markets that goes into more detail. I think a bunch of this is recorded, but hopefully this helps with a broad overview. Thanks. I'll take questions if anyone has. Yeah? Okay, I'll repeat the question. Before we release to the world, how long are we employee dog fooding and testing? So we have a cut every week, sometime on Sunday, and it's in soak period for 1 week. So 1 week soak and then release. And during this week soak, every day we release it to alpha. Like the master build is cut every day to alpha, and every day or two every day the master build is sent to alpha, and the beta build, the release branch one, is sent to the beta users. This is the time when we stabilize and we do not take new features, and we need to look at all of our crash reports to prevent issues from happening. But yeah, 1 week. Yeah. So yeah, so I guess to repeat the question for those who can hear in the back is, tell me if I got this right. I mentioned that there's a probability, like a probability commenting, probability of interested in comment that we compute in backend, and then you're asking, can we compute the probability of someone clicking? Yeah. Oh yeah. So we need some sort of validation, right? Like what percentage of people actually are clicking on this versus there was wait. Definitely when we look, I don't have the specific numbers here, but more people. This is a parameter that we're really trying to finely tune, right? You want to reduce false positives, basically the number of people that downloaded it and didn't click on it. I don't have exactly the right numbers, but that's something that we validate. That, like, in order to, like, this is like the parameter that we want to tune, right? But there is a non-zero. Like we download a little bit more comments than people click on. Mm-hmm. Mm-hmm. Can you repeat the question? It's like that, yeah. Yeah. Yeah, so the way we work is in terms of modules. Think newsfeed module, timeline module, messenger module. And a module is independent from actual build. So you can have a build, like the Facebook Android app is built with a module. And for instance, you might have this timeline module that is built, but we don't create like an APK for that. And it's just connected to the main Facebook app one. Messenger is a good example. You might want to connect it to the main Facebook one, and back when it was part of the app, or on its own build. So you create a build module that packages the app with a start activity versus just a library. We use Buck, so it's a Buck module. It's a Buck module, but not all of them create like apps to start, right? Yes, correct. And the other thing is that if you build the messenger module is built already, and I am working on newsfeed, I don't have to rebuild it, right? Unless there was a change. Mm-hmm. Yeah, in the back. Can you repeat that? I can't hear you fully. So I think this is we're not like specifically prescriptive on how each of the product teams should be handling them. So we know the API for a connectivity class identifies, hey, then what is the round trip time for each packet of more than 10 kilobytes, for instance, and tells you after averaging a bunch of them in like a window and throwing a low pass filter, it tells you, hey, this is low connectivity, high connectivity, etc. And it's up to the product teams to develop experiences for the users and use this information as best as they find. For instance, however, I think the API is not prescriptive. However, we have found that certain methods and principles help a lot, right? Having an offline mode, having a way to do offline retries seems to help a lot. Prefetching, as an example that I mentioned, is good, but there's different ways of prefetching. So this is something that we have to balance out. It's not as simple as we always need to prefetch, right? Mm-hmm. Yeah. Oh yeah. How do we deal with small devices? We have a device class too. I don't think this one is open source, but yet. But we have baby phones. We call it baby phones, normal, plus, and tablet. So we look at a mix of the resolution and the size of the screen, and we compute the different sizes. That way, we can make sure that our app feels like it's not just like a stretched version or a compressed version of each other. Mm-hmm. What do we do for instrumentation? Yeah, we do. We don't just do unit testing. We do. We have our screenshot testing library, which has been open source too. The idea of it is, hey, you take screenshots for all of the UIs that you create, so that if there's a difference in pixel, you get to see this before it comes out. So it's a little bit like unit test. It feels like unit testing in that sense. We have end-to-end test. We have our own internal custom build that is expanded from Android that allows us to look at core interactions. This was super important for us to be able to switch from a 2-week release cycle to a 1-week release cycle, because we need to check that a lot of our core interactions work, like, hey, scrolling through your news feed, liking something, commenting on something, and all of this works. Which machines you mean? Physical right now. And it's an interesting challenge to scale too. Cool. Yep. Yeah. I think a bunch of this relies on communication and knowledge spreading, right? When you have a 10-person team, if you have an idea architecturally of how to build something, you could discuss it and you know, hey, so-and-so is interested in this, and that works. So in general, I think one of the problems was that, hey, say you have 100 more new people working on this, and there's no set way of doing it. And you're wondering, say this dependency injection as a question, right? Like you send a diff out, and it's done by the way you researched it, however it was. You get a rejection because this is not using dependency injection, let's say as an example. Discussing the reasoning behind it, it's obviously very helpful, and this is what was happening. And eventually we decided that, hey, this is worthwhile. But the process issue here was that people did not know this is why we did this. This is the stack of reasons why we do things in a different way, and this is why this can help us scale. And in the end, this would cause a lot of contention and some more like discussions. I think they were pretty healthy discussions because we didn't have a good way of teaching people best practices. And by creating this bootcamp series where every single new person that joins the company gets to understand how each of these things are done, they're not set in stone. We want to explain them to you so that if you have ideas of what to change, you understand the reasoning behind the current present, right? So it's a little bit more like that. And I think education and dissemination is a lot more important too, which in a 10-person team is a lot easier than with hundreds of people joining, right? Any other questions? Cool. Well, thank you very much for coming.